All right. Hello, everybody. Hello from my favorite artist, electronics, Mr. Q12, with a new and exciting subject. Well, I did some progress. I learned something new, and I believe you will learn something new along the way, along with this movie that I'm making here. I don't know even how to begin because I made so many changes in this folder. But let me start with the very beginning. Here in my D drive, electronic and boards, you can follow this route here on the top. I have this folder, I2C, OLED, LCD. Actually, it's not an LCD, it's OLED display, 128 by 32 pixels. And the chip that is using is called SSD1306, the driver chip pretty much. And interfacing between your device, your microcontroller, and the display itself. So this is the heart of the module pretty much. Unfortunately, I didn't see the chip itself. Probably the chip is underneath. So this is the module that what I'm having, the actual integrated circuit, and I believe it's underneath, under this glass display, is stuck. It is stuck underneath it there on this flexible band, most probably. As you can see here on this back side, is not having anything. I believe this is a voltage regulator here for 3.3 volts. Here on the top is receiving 5 volts on ground, and these are the data lines. Well, serial clock and serial data, and here is receiving 5 volts. And I'm not sure if anything is using. I believe that the LCD itself is using 5 volts. Actually, the LCD itself is rated to 7 volts, if I remember correctly from its datasheet. If I understood correctly, this is a 3.3 volts voltage regulator. Most probably it is powering the driver chip, which is this name, SSD1306. Here is its datasheet. That's why I know that this name is the actual, yeah, you see here, OLED, period, segment command driver with controller. So let's see the actual chip. Yeah, it's a long motherfucker. It's a big motherfucker with a lot of pins. That doesn't say how many pins. I believe 281 pins. I didn't stay and read the datasheet, unfortunately. It's probably this yellow thing that is on this band, a pin assignment. Here, these are the actual pins of it, starting from pin 1 and 207 pins. Fucking hell. Yeah, it's a big chip. It's having a ton of outputs. Most of them are outputs. Some of them are common. All these common are for different display modes. I believe this chip can do more than this. It's not really dedicated to this type of OLED. I believe he can lift more types of displays, like LCD displays, those black and white ones, and most probably even color displays. But this OLED display that I'm having, this model of display, is only one single color. It's a monocolor display. So this is the guy that I'm having, the cheapest one and the smaller one. And I believe there are even smaller than this, half of it. I believe it is, because I looked on the driver inside, and it was mentioning the size. It's not saying here. So 128 with 34, and I believe I find inside the driver in Arduino, I find 64 with 32, so exactly half of this display. That is probably not that commercial. I don't know. It was a test some time ago. They tested it as how small you can make stuff, and they put it away, and they make this version commercial. The idea is that this display that I'm having, and most probably all of these displays that are showing here, especially the OLED displays, are monochromatic in the sense that it's having only one single color, and also as a deficit, not a benefit, but a deficit, is that the pixel that is lighting up is either on or off. It doesn't have any kind of transition, like multiple grays, doesn't have that. So you cannot dim the pixel. It's either on or off, and that's it. And I believe, but I didn't test it yet, you can use PWM to dim the pixel, I believe. But I'm not very sure because I didn't test it yet. I didn't check for that. So this is the OLED display. I have this very interesting little picture that I find it on internet, of course. OLED display modules classification is not that complete, but it is giving some idea what is out there, what to look for. It did help me a little bit. As you can see, it does clearly say here, these are monochrome, but they are the same dimension. It doesn't include my version that I'm having in this image. And also there are color OLED displays, and from what I read, they are even shittier and even more sensitive to a problem. The problem is called image retention. It's happening when you keep the display on for a very long time. Well, very long. For a longer time. In my case, I leave my display open for 8 hours over the night while I was sleeping, and when I wake up the second day, when I tested my LCD, when I lit up the entire full screen, all the pixels on, the shape of the thing that I was holding all night long, they were two eyes, two circles. They persisted on the full lit display. And after I've seen this little problem, well, little, this is a big problem actually, because your OLED display will die very, very soon, very quickly. At least a couple of pixels or a series of pixels from your OLED display will die quite young, quite early in the evolution of your tests with that display. You will start to see decaying pixels and everything. Monochrome displays are tougher in this problem, so the pixels are not that easily decaying, while the color ones are very extremely sensitive, are even more sensitive than the monochrome ones. Why? I don't know why. And especially the blue pixels. And my display, what I'm having, coincidentally, it is having blue pixels, and probably it is the same as the color one. Who knows? I'm not sure. As the same sensibility, but that's the problem, and that's not advertised or put public in the datasheet. But the datasheet should put the very first line of properties. It should warn about it, not to let you discover in time that your product is actually shitty, and you have to take care of it somehow, not let it lit too much time. And if you ask me, 8 hours is not that long time. So in other words, this type of display, OLED display, are not meant to function all the time, day and night, non-stop, 24 hours. You know, they are not designed to work like this. That's a big issue with them. I didn't know about it. I discovered it with my tests that I did, and I did a ton of tests actually. But let me reverse back how I begin everything. So this is the OLED that I received it 3 years ago, exactly 3 years, because right now is summer. This is July 2025, and the date is 14. I'm using Windows 11 for a while, but I will revert back to Windows 7 because this is a piece of shit, this Windows. Nobody likes it. Everybody is forced to tolerate this type of Microsoft system. It's a very, very bad operating system. It's extremely bad. Compare with Windows 7 and Windows XP. That's what I'm comparing it with, and that's why I'm saying it's very extremely bad operating system. It's having multiple shells than the original shells Windows 7 and Windows XP came with. So they've added even more shells on top of those shells that they were originally there. So that's why it's very bad, because of this multiple shells, one on top of the other. From my understanding, at least. Maybe I'm wrong. I hope I'm not wrong. I hope I understood it right. So, getting back to the problem, this is exactly 3 years ago. Now it's 2025, and I bought it in 2022. And I paid $350, including the transport. So this price is including the transport. The actual OLED was $1.72, but plus transport, it taxed me very hard. So that's what I wanted to show you, this I2C price and date when I bought it. So this is the very beginning. This is the starting. Recently, I was looking through my boxes, and I find this LCD that I stored it in one of my boxes, and I believe I started to completely forget about it, to forget about its existence, that I even have it, because it was only one piece. I bought it for testing. The time passed, and I was concentrated on other projects. I delayed the testings with this specific component, and I started to forget about it. And when I was searching for something in my box of boards, I got over it, and I said, well, this is perfect, because I really wanted to integrate, to use this OLED in one of my projects that I will build very, very soon. So that's the history how I started this project with, because I wanted to actually test the LCD. I'm saying it's an LCD, but I know it's an OLED, but my mouth is running ahead of me and is calling it as LCD. So I'm making this mistake, but deep down I know it is an OLED. Make abstraction of little mishaps, of some mispronunciations sometimes. Maybe I will do them without thinking sometimes. Because I'm concentrated on the big picture, how to present all of this shit, because there's a lot of stuff to present. That's the problem. By the way, with this occasion, I have to mention that this is absolutely my very first time using this type of component. This OLED, this is absolutely the very first time when I'm using it, when I'm testing it, when I'm playing with it, when I'm coding it, when I'm powering it. Everything is the first time. So I'm pretty much virgin at this point. Well, not right now, because I have a couple of days of working with it and making all these programs that you are seeing here inside this folder. All these folders, they contain Arduino programs, and I tested the shit out of it, and I will present all the programs because this is the movie about. But I have to mention this very important detail. This is the first time when I'm playing with it, and don't expect very professional presentation about it. I'm only presenting my fucking experience with it, okay? And having someone presenting its experience is worth 1,000 professional explanations, in my opinion. But it's good to have a good data about the component that you are playing with. But it's also good to see other people's experience. Is my very strong opinion, actually. I'm counting on, and I'm learning more from other people's experience than simple, repetitive, the same information everywhere. That's quote unquote is professional. Okay, so this is sincere experience, is what I'm saying. Alright, how to even fucking start, because I don't know how to start. The order of the folders that you are seeing here, I changed the content inside this folder. I changed it like 100 times. I renamed the folders between them. I reordered everything probably 100 times, because I started in one way and I reordered everything to be more clear for future me and also for you as a viewer. In the beginning, I was having a couple of programs, like 10, maximum 10. But then I realized I will have to make more testing programs, and this list with programs will get longer. So on the way, I changed everything, all the names, I renamed everything. And I believe, yeah, you see, this is the basic codes that I started with. This is the actual order of them. And let me actually take out a little bit this content file that I was very, very smart about it to make it is a simple text file that saved my ass literally in all this experimentation with all these folders, with all these programs. This is how I started everything. But here, let me open this other content. This is the most recent one. If you are looking on the name of the program, this is what the program is doing actually. Short explanation of the program. So this is the old one. I started directly with text. I jumped directly into text. I wanted to see if I can write text to the screen, pretty much. That was the very first program. But here in the most updated, exactly on this folder list that you are seeing here, this what you are seeing, this content, this text file, everything that you are seeing here is a reflection. I'm updating all the time what I'm having here into this file. I'm that meticulous. So because this helped me a lot along the way. But now let's get back to the comparison. When I started with, to render simple, very limited custom size. I don't know what custom size I did then. I believe I was learning, I was getting acquaintance actually with different fonts from the library, from the graphic library that I will talk about it later. So after I downloaded this library, Adafruit GFX, that is having a dependency, is dependent on another library, either this one or this other one. I remember someone, it put me to download something else for this library to function. So under the hood, there are these two libraries that you are seeing here, plus one or two other that are not visible to properly drive this OLED through I2C protocol. So this is the graphics actually from Adafruit. GFX, it means graphics from Adafruit. And this is the actual driver, I believe, for the chip that is communicated. Probably this is for the I2C. I'm not completely sure. And this is actually sending all the text, shapes, all the graphics, all the pixels that you are commanding, that you are requesting to display on your OLED. There. And I have here wire.h. I believe this is actually the I2C. I'm not completely sure what is what. And there is another one beneath everything. But I know for very sure, because I actually downloaded this library, this GFX. I have it here. You see, here is the PDF, and it is relatively long. But this is the actual library from GitHub. I downloaded it, and I store it here as a zip file. If I'm entering inside the zip file, you can recognize that it is inside these headers and the C++ file next to it. I believe that's also a type of header. And also is mentioning here GitHub, you see. But also is having these examples, and I will get to them very quickly right now, because that's how I started everything here. The very first test programs that I started with, what I actually did was to go here into File, go to Examples. I believe here an SSD1306 I did here. And I choose my version of OLED, which is this 128 by 32, and to be I2C, not SPI. As you can see, they are the same, 3232, and this is 6464. This is another model that I don't have it, and this is the smallest one that I mentioned about, but is not commercially available. But here it is. Here is the proof that it is existent. It exists, but I didn't find it. So it's literally half of my display that I'm having. So this model is actually double from this one that I'm having, and I have the pictures to show you. So this is my model, and this square one, actually I believe it's the size, yeah, the size is in inch, but it should and I should update this picture to actually include the pixel dimension. Where are you? Yeah, it disappeared. So it was in examples. So here I should include this 128 by 32 and 64 respectively per each LCD to be a bit more clear, because having it in inch is really not that clear. It's a lazy job here, but it's a good overview of these LCDs. It's a very good overview of it. That's why I like it. I really like these bigger ones, but I don't have money for them. I will have to suffer with this smaller and shittier one. So I got here, where are you? Here, and I choose this program. Actually, I can open it, and it is open right now. I can close this one. I don't remember, I really don't remember if the original file came with this binary or it came with hexa, and I converted it here in binary. I really don't remember this part. I believe it did came with hexa numbers instead of this binary, and I converted, and then I save it on top of it. I will come back to this part later, because this is a very important thing. Or maybe if it was originally here, then it was a very good, extremely good hint what I can do, and I did it this way all the time. If not, then praise, glory to Q12, because I figured it out by myself how to convert that hexa into binary and then use it only in binary all the time on the rest of the tests that I did. Okay, so I use this code, which I will not present it here because it's beyond of the scope of this presentation, but I literally look on the screen of the LCD and I've seen it how it was running, what it was doing. I can actually film it, but I have to prepare a little bit. I have it here next to me, very close to my eye, to quickly look in the left side and to see exactly what it's doing. But right now for this movies, I will have to make another setup to be able to film it, and I will do it right now. All right, so this is the setup that I have to start with to show you how I linked, how I wired everything. This looks like it's the first 5 volts, the first wire, but is actually going into the second pin there. Is here on the second pin and is exactly on the VCC, and the first one is the ground, which is this black wire that is going somewhere there. You can follow actually on the board is saying that is 5 volts and that is one of those two is ground. You can put it either way. And here is analog 4 and analog 5, which represents serial clock there and serial data. And that's it. This is all the setup. All these 4 wires from Arduino are directly connected to the pins of the module, and that's it. All right. So I hope everything is in synchronization. Yeah, I wanted to show you this test program. The first thing that I did, I actually followed a tutorial, a very simple tutorial. I have it here, this too. Yeah, let me actually show it to you because I downloaded the website. The website is very easy to download, and you can go find it. You can type this name and you will find it on Google. Literally, I followed all these directions and all this setup that he is doing here, that he is presenting, especially for this OLED. You see it here mentioned 128 with 32 as well here. You see 128 and 32. So I hunted specifically for this OLED, not for other types, because this website, this guy that is making all these tutorials, is having a second tutorial. This one, let me open it, about this second type of LCD, which is a bit more larger, bigger than mine. So originally I find this, but it didn't look like mine. And after I searched a little bit more, I find specifically for my, and after I figured out what the dimensions are, that mine is 128 with 32, and this more popular OLED display, but more expensive than mine, is another, where are you? Another format. Yeah, finally it's saying here in the bottom of it. So this is its dimension compared with my dimension with 32, and this is for the 64. So this is how I started. I actually downloaded these two websites and I put them into a zip file here. Very easy to access them very quickly. You know, if I will have a problem another time, I will delete them because I don't need them anymore. But in that tutorial, I find what drivers I need to download and to install in my Arduino, and that's how I started everything pretty much, with a very small and to the point tutorial, and very easy to pass over it, to go over it, to think that there are better ways, but that's the better way. Let me run this. So I'm uploading it to the Arduino. Yes, good. So this is the sequence of graphics from this library specifically, and it's showing all these very nice graphics, and I was actually very impressed by it. I hope you are impressed by it as well. And when I've seen what this LCD can do, I wasn't thinking on the library itself, I was looking on the LCD, and this is it. This is the final animation that is repeating continuously like this. And after I realized what is capable of doing, then I said to myself, well, I got courage and I said, well, this is simple. Well, it's not that it's simple, but it's a thing that I can do. I started to trust myself I can do it. Imagine all this presentation made for a PIC microcontroller. Holy fucking shit. But here with Arduino is way more easier than with the PIC microcontrollers to make the comparison with those little pieces of shit. Alright, this was my first step, my introduction. This is how I got myself introduced to this GFX library, and then I jumped directly into ChatGPT. I started to ask questions. What is making it running? I actually copied the entire program that you are seeing here. I make it like this, Control A, Control C, and Control V, or paste inside ChatGPT. And I asked him, based on this entire code, what is making it tick, what is making it function. And he pointed straight away about this library GFX that I never heard of it. This was my first encounter with it. Like I said earlier, this is my first time working with this OLED and this type of component, and that's why I was very easily impressed by it. I'm not 100% sure everything ChatGPT is saying is true, but it did push me in the right direction. I mean, I got used on using this library. I learned it. I start to get comfortable with it. While in the beginning I was a novice, I was a rookie. I didn't know where the fuck should I look. And with time, in a couple of days, by the way, let me mention this little very important detail, that all these test programs that you are seeing here are made in a couple of days. They are not made in one single day. They are made in a couple of days, and if I remember right, it took me like probably 10 days, something like that. So 1 week and a half, something like that, around 10 days. And I worked slowly, meticulously. That's why you are seeing my content file here that is in synchronization with all these folders here, because I was very slow. I took it slow, and I took it gradually. You know, I started with very simple programs, and then I started to add more complicated stuff. Let's get back to this first file that I started with, and that I told you that here I started with these programs. But these programs, and I wanted to say that these programs are based, this example here that is opening here, and You can see those stars there. So after I've seen this program running, I said I will make my own programs. And these are the first three programs that I got inspired. And I started making my own little programs. I wanted to cut down the bush, you know, to the essence, to the core of the problem, to see the basics. I started to search for the basics, pretty much, to understand how to do it myself. Unfortunately, these names here in the front are not here anymore, but these names are. So we can find them. I'm not sure if it's a good idea to start with this or to continue with this. I'm not sure because, like I said, I changed a lot of namings, the orders of everything. I don't have it as in the beginning. So let's say simple text. So here where I'm having this text, here is the first one. Okay, so text one is actually the first one. So I will run this. What I did here, simple text with limited custom size and font. I was testing. You see here, I was testing the fonts. I was playing with them. I was trying to understand them, which is the smallest font. And I started to learn which is the biggest font, which is the smallest font. And I started not to like this default font because depending how long text you want to write there, it depends what size of the font you will use. The fonts are very limited. You cannot change their height. They have only specific heights, and that's it. You have to deal with it, and you have to find a way, work around this very serious limitation of fixed size. And this I didn't like it, but for this first test, what you are seeing here, I was playing around. I cut the bush. This entire code, what you are seeing here, I extracted from that example code, so it wasn't my code per se. I just borrow it and I play with it, and then shit. Example, I will have to load this again and upload it. This one. When I seen this one, I said, aha, it is scrolling, is going outside the screen, and I can scroll it like that. So this is what I put my eyes on, and what I did, pretty much I copied that part of the program, and I made this second program for myself. Let's see, scrolling continuously, very small text is text 2. Okay, so text 1, text 2 here. So these are my very first steps when I started everything. Let me upload it. If you are writing something longer than that string, so this is the text that I'm displaying there. If I'm making a longer string like this, and I'm uploading it right now, I will have some problems. Yeah, you see the problem. And you see it's cutting here on the second line, and is auto wrapping the text. At this stage, I didn't know this wrapping option exists. When I observed that it's doing this automatic wrapping, I didn't know how to unwrap it, to make it continuously. Later, I discovered that in the library, it is having a setting for displaying text in this wrap or unwrap. But at this point, I didn't know that. And I said, well, I will have to find a way of making it scroll for a long string. So these programs are actually in the same order as I begin everything. And now it's a little bit hard to remember how I started everything if I didn't have this file saved, put aside, using this wrapping as false. The default is true. So this is specifically making it false. But I didn't know this little detail back then. But now when I'm looking back, I'm searching for this function actually because I've seen it. But I wasn't really aware of it when I built this code because I copy pasted pretty much. And yeah, this is the text. This is the string. It's a very long string. And I want it to be on the same line, not to be on 2 lines. So this is one single line of string of text circling around and around pretty much. Later I understood all these are functions. This wrapping thing are elements of this GFX library, Adafruit GFX. I'm not completely sure about this SSD1306 because I didn't enter into it yet. I only specialized or concentrated 100% only on this GFX library all this time, in all these projects, in all these test programs that you are seeing. Then I started to search for some programs on internet that are already made by other people. I find another tutorial that was more complicated than this too, and I didn't save it because that was 9 megabytes space occupying, and it was good, a good tutorial actually, but it was stupid big. I don't like stupid big, and I did put in my mind that I will make my own test programs anyway, so I will not need that tutorial anymore. Let me see if I can find it again. Oh yeah. Yeah, this is it. All right. As you can see, so I did search for my display, but it gave me this tutorial, which is not for my display per se, but is using the same chip, this driver, SSD1306, that is common for this OLED and my version as well. And I looked and I read everything, and I compared how this was linked, compared with what I'm having there, and it was pretty simple, pretty intuitive. Also, I looked on this libraries that is using. Yeah, you see here how he is using the same example, but he is using the example for his display. Here is the 64 version, while mine was 32, also I2C and not SPI, because these two are different communication protocols. This code, what he is having here, is actually this code that he took from this example and is running here on his display. And here are basically a tutorial about how to write text. Scrolling text, I didn't read the entire tutorial. I only fly over it like I'm flying right now. I'm scrolling down and I'm reading the titles. And I've seen that you can do this graphic stuff. draw a pixel, draw a line, draw a rectangle. And after I've seen this, I said, oh, cucaracha, I have to try it myself. And I didn't understood what these functions are. And these are those GIFX library functions. This function is from that GIFX library, all these functions that are mentioned here. But I didn't really read everything here on this page. I should have, because it should have pushed my understanding a little bit faster. Maybe I lose one day by not reading this tutorial from top to bottom, only flying over it. But this was very, very helpful because it showed me what you can do with this display. And after I've seen this stuff, I was surprised and a little bit amazed, actually, what you can do with this very tiny little shit called OLED. Again, my first time again with it. And then he is jumping into displaying bitmap images. And he is using fucking Paint program. Really? That's not a good program to use. But apparently it is doing the right job, apparently. I didn't read everything here. And after I've seen this little detail that he is using there, meaning that you can convert images, bitmaps, and actually show them on your display, then what I did, I searched a website. Let me see if I can find that website again. I have no idea where I can find that website. I believe this was the one. So what I did, I took this drop from internet. I downloaded it on my PC. After that, I crop it. I made it exactly from here to here and from there to there, exactly, not too big, unnecessary space. And then I imported it here into this website, you see, image to CPP, and I selected from this browse button from here, and after it loaded, I got here down and I pressed the generate code and it gave me the code. Raindrop is in the graphics here. So graphics 01 is actually, this was the first graph 01. So this is graphics 01 upload. And I was extremely amazed that I managed to do it myself. And as you can see, probably, yeah, you see here, this array, so image data Sara array, all this stuff that is having here is in hexadecimal. So originally when I converted, I believe here, when he generated the code, I believe it generated also in hexa, this website. But what you are seeing it here, I should repeat the process here with you, but I'm lazy. Let me actually take a random picture just to check if that is binary or hexa, what this website is giving you. All right. So this is a preview of a cat, and let's see, generate code. Yeah, so I was right. So this is giving you the hexadecimal code that you are inserting it here to display your image. But what I did, I really don't like hexadecimal. I mean, it's good for some things when the binary is too long to write, when you have a lot of data in binary. The hexadecimal is shortening the data pretty much. But in this case, having it in hexadecimal is a bad thing, very, very bad thing. And I will explain it, and I will elucidate it, I will clarify it right now. You see my drop image that is displayed there on my screen? You can actually see it here in binary. And when I'm saying you can see it, you can actually really see it. Trust me on this. Let me actually zoom in a little bit more and make a drawing on top of it. So we are following the ones. So here is a one, and here, you see it? Then here, and here, and here, and here. All those ones, and this, and this. And it's going down like this. You see it? That. All those ones, there, and there. And here is like this. So this is a drop image, raindrop image. It's looking very weird, but it is. So inside, as you can see, is having all these ones inside. On this side, and also on this side is having all these ones. But let me choose another color here. But on exterior is having all these zeros. You see it? All these zeros exterior. Zero, it means blank. Do not draw anything. Pixel off, pretty much. And all these ones, it means pixel on, activated. And this is how you can draw using binary. You can actually see the image that you want to draw. And that's a very big thing, a very important thing. And I hope it clarifies everything. Let me draw it again. Now when it's a little bit smaller, and you can see it here, like this. Like this. Like that. You see it? It's like a drop. And of course, you have to imagine that all these pixels are actually squares, one near each other, and they have the same width and the same height. They are literally squares, and all these ones represents a pixel that is lit 1. And you have to mentally make an effort to imagine this picture that is a little bit wider than here in this text mode when it will be rendered on the screen because of those square pixels. So it will be a little bit more like this because the pixels are more square. So this is the shape that you have to visualize it with your mind. And it is the same shape here, even if it's having that pointy top here. But because there are literally 2 pixels there on top, it looks from a distance looking like it's having a pointy tip, but in reality there are actually 2 pixels lit out there. So this was actually my invention to transform all this hexa into binary. This was my invention. This was my idea. And I drive with this idea the entire process with all my programs. Okay, so this is the third program. And I will fly over the next of programs, I hope. Square line. Yeah. Then I said, let me make a shape, because until here I tested these tutorials. So these 4 test programs, I was testing the tutorials, I was testing the example program. So now this is my actual first program that I did, kind of, without holding hands in a way. So let's see, square line, graph02, upload it. And actually you can see, if you are looking here, you can actually see, if you are following the ones, you can see the fucking square, which is not that square, but these are all the ones there, you see? Let me close. So you see, these are 1, 1, 1, 1, 1. Here, all this entire line, and this entire line, and here as well. So this is my square. I want to make it clear how easy it is to visualize it in binary. If you didn't know this detail, well, this is your learning time. This is your aha moment. Aha! Like it was for me many years ago, when I was adolescent, when I was a young pup, when I was learning stuff from others. Like you are learning it from me right now. And then I made this square, I tried to make it move, the next program. So square moving is graph03. So graph03 here is the same square. You can see it here and here. Follow all those ones on the vertical as well, and you will see it's a square. And let's run the program. I'm not sure how good my camera will catch this relatively fast moving. On the screen of my phone, I see it jagged when it's moving. I hope in the real movie, it will be smooth, because in reality it's very smooth running. I don't see that jagged effect that I see it on my monitor screen on my phone. All right, so this was this moving square, and then I looked on internet and I find this little very helpful program. And at this point, I decided to change the naming of everything. At this point, when I find this program, that is a very good, very interesting program. It is showing you the address of your I2C address of your device. Doesn't matter what device you are having. The important thing is to have it connected on your Arduino, and you run this program, and you find what address it is running on. So let me actually run it. Very cool program, very helpful, very helpful. And it is not having that much of a code inside. I'm believing it is using the serial monitor. I hope it will work. Okay, so let me upload it. Yeah, you see, it's saying here I2C scanner scanning. I2C device found at address 0x3c. This is hexadecimal. So this is the address that you have to add, and I had to add in all my programs. I already managed to make everything work because I was using that example test program from Arduino, like I showed you, that Adafruit test program. But later I find this program that is very helpful. If you have a I2C device connected to your Arduino and you want to write to it, you want to communicate with it, and you have no idea what address it may have. And this can solve your problem very elegantly and very easily. It's a very good piece of code to have around. So at this point, I changed the entire naming of everything. I leave this as really it was a basic program, and you can see it here as well. This is my first program here, basic 01, and I made other basics, other graphics, and I renamed properly everything else that I did after that. This is from a guy from YouTube. I followed his links. He provided some links under his video, and I got to his website, and I managed to get his code. But again, like this guy here, he was using this kind of OLED size, this 128 with 64. And the code that is running on this kind of display, it will not run correctly on my type of display, my 32 type. It will be very erroneously. It will run, but with a lot of errors. So you must have the correct program for the correct OLED format that you have, 32 or 64. So this guy, not this one on this website, this guy here from YouTube, basic 08, show voltage. Let's see, where are you? Text 04, text 04 here. Let's run it. So that guy have it in that format, so I had to change it in my format 32. So I converted his monitor size into my monitor size, but the rest of the code remained relatively the same with little tweaks here and there. And for those tweaks, I used ChatGPT to correct them for me. So I told you I did use IE tools, and it's running absolutely fine. The same code that guy had it on larger display, on my display is running. What this guy from YouTube did, actually, he did exactly what I did in the very beginning. He took this example code, he cut the bush, unnecessary stuff, and he made, on top of it, he made its code. And that's why you've seen here And in the beginning, it started with Adafruit, and then it is displaying all this data that you are seeing there. And of course, this is not reading anything right now. This is just a displaying operation, displaying exercise, and also temperature is not real. All the data what you are seeing here is just for testing right now. So this is the program from that guy from YouTube. I managed to convert his size into my size, and it's working. So glory for me, glory for Q12. Testing text code. I have no idea what I did here. So text 05. Let me actually remember what I have. Now I get crazy at this point. Let me upload it and show you. What I'm having here are numbers, but as you can see, they are in hexa. But later I will convert everything what I'm having here in binary, and it will be a bit more easy to visualize what the hell are everything. You'll see in a second. I don't remember from where did I get this code. Yeah, scrolling text demo. Probably I find it on internet somewhere. I have no idea. Or this is another test program. I have no idea what I did here. But I was testing stuff. I was testing stuff, and I realized that I can make my own characters, my own fonts, my own font size. This is what I was after, to make my own font size and to be able to change the size of the font. Because the other version of texts that I've seen, the default ones from the library and what I observed until this point, is that you cannot change the size. Actually, you can change the size, but very brutal. Like 2 times, 3 times, 4 times, and it will get out of screen very quickly. And I wanted a floating point magnification, not an integer magnification. Integer meaning 1, 2, 3, 4 times, and floating point meaning 1.5 times, 1.8 times, something like that, or 0.8 times, a little bit less than 1, and so on. Here is my next move when I'm actually converting all this hexa into binary. This is the one. Okay, everything is in order. 606. And I still have it in hexa. Probably the preview code I copied from somewhere, and here I cut down the bush, and I try to understand it a little bit more in this version. So here's scalable text in float units. So this is the one that I converted actually into floats, and binary characters. And here I started to make the character, but in binary, and I use this text file to create the shape of the character that I wanted, or the symbol. Let me actually run it, upload it, because this is a little bit more complicated to explain, but I can explain it. But it will take some time. I believe I have multiple functions. Yeah, I was testing multiple functions here for drawing only the numbers, the uppercase letters here and here, these 2 lines, then the lowercase letters, these 2 lines, and then these symbols on 2 lines. To have why on 2 lines? Because I wanted to see them all. And I actually looked with my magnifying glass. Here, this is my magnifying glass. And I was looking very closely on all those pixels where they are positioned, and I was correcting each pixel where it should be. So I did spend like 2 days, something like that, on creating manual characters. With this occasion, I learned how to create my own very custom characters and symbols. So how this is working, because this is in binary and is looking like crazy. You are looking at it like it's something from outer space, something alien, but it's not that alien after you will understand the idea behind it. And the idea is very simple actually. What I'm doing right now, I will copy number 1, all this string. So I'm having this font is 5 by 7 pixels. Literally. So 5 times 7 is 35 pixels. Square is a square with 35 pixels inside it. And inside this 35 pixel square, you can model everything that you want. Every character, every number, every symbol. So that's the idea. And I copied that number 1 string of numbers. And what I was doing, all these exercises you are seeing here, these are actually corrections. But right now I will make a test demonstration for you to see how I was doing it in reality. This is how I was doing it. I will zero it, everything to 0. Like that. So right now it's having nothing here. So these are all blank or black pixels. There is absolutely no shape at this stage when everything is 0, 0, 0, 0. Okay. So what I'm doing right now, I'm doing this. I deleted that bracket in the beginning because I copied with the bracket from here, the first bracket. So I deleted that there. And next I'm doing this. I'm pressing enter on my keyboard and I'm lowering everything down one on top of the other. And I will make this one to be on this side. Let's see. Okay. So this is how it's looking originally. This is the number 1, like with the raindrop image that you've seen earlier, and with the cat image. So here is number 1. You see this 111 here, 11111 here, and another one here. You see, but it's on a side. You have to flip this image in your mind. You have to flip it on a side. So every character that you are making, every number, every symbol, you have to flip it on one side. So right now the original one is centered here in the middle. So right now I will make it here a little bit uncentered. So I will make it like this: 1111111. here is 1, 2, 3, 4, 5, 6, 7. Remember here, the font is 5 with 7. So until here, so this is 1, this is 2 here, and this is 7 here. This is 7. And this is the 8-bit here, but because this matrix is only using 7 bits here, all this element that you are seeing, all these bits, all this matrix of bits that you are seeing here will not render the 8th column of bits. It will render from 1 to 7, and that's it, because of this array. And it took me some time to figure it out. It wasn't obvious, like I'm telling you right now. It wasn't that obvious. But then I figured it out after some a lot of trials and errors. We have to omit this line, this column here. We have to neglect it. We have to omit it purposely. Be careful not to put any pixel there, because it will not be renderable. The display will not show it. So this will be an error from my side. If I will put here on this column, if I will put some bits here, it will be my bad. So I will put this 1, 1, 1, 1, 1 there, and I will put I will make it 1 here. This is exactly how I did all these numbers and all these characters and the lowercase and all these fucking symbols here. Oh, the fucking shit. It took me 2 days, and I stayed non-stop. I don't even know how many hours I spent. I was crazy, a little bit crazy with it. But it was interesting. So let's continue on making this number. I will comment out this line. And this, how I will transform it back into this line, very, very simple. I will put another bracket here, and I copy it from here, and I paste it after this bracket here. And now I'm pressing delete button on my keyboard to delete one space, and voila, I'm having the same syntax as I'm having it here. So I copy it from here, Control C and Control V, I'm pasting it here. I comment out this original line, not to delete it. So now my one is custom made, is a little bit shifted, like I'm showing you here. Instead of being in the middle, central there, it will be a little bit on the left side. If you are rotating, remember you have to rotate all this matrix in your head. Now let's run it. You will see a larger gap between 1 and 2 next, because everything will be shifted. Yeah, you see, 1 pixel, it's a little bit of difference right now from before. You see, it's a little bit like that. Let me undo back everything I did here, because I want to preserve it as it was, because I worked on it like an idiot. But it was a good lesson to do it like this, to figure out everything, to play with these binary shapes, to visualize them, to get used to them. So this is it about this program. Here I made another, and I believe it's this one, X09. 09. I'm using the same font, my custom font that I created. Let's upload it. Like I said, originally I wanted to make my custom font. Why? Because I wanted it to be scalable. I wanted it to be able to scale it, to change its height as I please, pretty much, from a variable. And let me find that variable. Oh, I didn't see it. I forget about it. This set scale. Okay, 1.3. So let's say 1.6 here, and upload it now. Now it should change the size. Okay, and now 1.0. Yes. All right. I didn't see this little function that I'm having here. I cross over it with my view. So this is where I'm setting the scale of the text. So right now is 1, and you can see it here in my video. And now if I'm scaling it to 1.6, and save it and upload it. But the characters are changing a little bit. They are not the same as when they were very small. The shape is a little bit different, but the difference is not that big. You can still read, you can still understand the character. But my mistake doing this custom text thing, what you are seeing here, my mistake was to make it as small as this 5 with 7 pixels. This was my mistake. I wasn't aware of it. I was concentrated how to do it, not why to do it. It's better to have it now in retrospect, after I did everything and after I fight the battle. I'm thinking it's better to have a better size font, a greater, bigger resolution font. I don't know, like 25 with 70. Big or stupid big, you know, very big. Big as the screen, what I'm having, for only one character, and then lower it, because lowering it will compress the pixels, but the shape will maintain in a large degree with the original. It will be the same, pretty much, very, very the same. But when you are scaling up from a low resolution to a higher resolution image, it will distort quite significantly. Not very much, but annoyingly enough distortion. Very annoying. Some parts will be annoying, because the algorithm of converting it to a bigger font is not that good. It's good, but to a point, to a limit. So that's one thing that I didn't think about. But as you can see, as you can observe, I did it. I made it scalable. Like I said, I'm using a float meaning that I can add a comma, 1 point something, and not only an integer scaling, only 1, 2, or 3 or 4, and that's it. You know, and here is the function that is using that floating element and is creating all this wonderful stuff that I can do here. Let's see how it will perform on
3.6. It will be much more bigger than what you are seeing here, and it will get out from the screen. That's what will happen, if I remember right. Ta-da! And also it will be misaligned because the alignment, I believe, is draw scale string here, I believe, is where you set the X and Y points, the character to start. The spacing between the characters pretty much is what you are setting from in this function. And as you can see, my letters are scaled up, but they are also one on top of each other because I didn't made a proper adjustment on the distance between the two lines of characters. So that's another point to keep in mind, to adjust this as well. But for the moment, mission accomplished. For this entire starting tests of programs, mission very fucking accomplished. So I was very happy with the results that I was getting here. So I will close this beginning content, and I'll try to get over all of this very quickly, and I will jump over the ones that I already mentioned. From now on, it will be a little bit more simpler, not that complicated, because the complicated part I already explained. I covered all the text files because this is what I started with. And after this texting exercise that I did here, and all my custom characters and everything, and all the problems and scaling stuff, I did learn quite a lot. And I started to put questions. It started in my mind to appear this question of where this text font is coming from, the default one that is coming with the library. And I started to ask question about the library itself, and I started to learn about the library. And then I started to actually make more serious graphic programs, and I have a ton of them. I have 20 graphic programs. I already started with this static raindrop that I already mentioned, or should I jump to the basics first? So this one I already explained. Draw some pixels. This is pretty basic, but it's not that complicated. I made some functions here, and I'm calling them all these functions. I'm playing with pixels. What I'm doing. Let's see how it's looking. It's very simplistic, but it's quite interesting. I like it because of its simplicity. It's kind of reminding me of the 1980 movies with those ship flying in the cosmos, spaceships panels, and they were beeping like beep 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 when you are closing or distancing from some objects or meteorites, or when he was finding his target to shoot at. That's very simplistic, very minimalistic, and very retro looking actually, and I kind of like it. Quite a cute program, I may add, as simplistic as it is. I actually started with the one in the very middle, and with the 4 points in each corner, in the exact corner. Actually, this is the actual size of the screen from this point to there to there to there. It is having a margin of a black margin all around, so the screen is not from here, it's actually from there, from that pixel. This is 0, 0, 0 pixel there, so that's at 0.00, and this is 0 with 128 here, and this is 32 with 128 location of the pixel. Then screen off. These basic programs that I'm having are helping me to not overwhelm the screen, the display, because like I mentioned already, I had some problems with it. So let's say basic 3. I only show the code. This is all that is doing, is clearing the display, and that's it, making the screen complete off. That's it. You will see actually this function repeated in all the codes because this is used all the time. But here is to shut off the screen only. And next one is screen full lit. Yeah, I can see it with my eyes. I was actually worried about this problem. If you can see it, yeah, you kind of see it, but it's very extremely faint. Do you see this circle here? And here in the middle is another circle. So this from here to here is faded. It's like a donut. It's like an eye. And here another eye. Do you see it? So from here to here is like a donut, and another circle here in the middle. So these are 2 eyes that I had them. Yeah, kind of, you can see it. It's very faint difference, very subtle difference, but it is a difference, and it should be all the same lit, not with that 2 eyes there. Well, lesson learned. This was a big mistake, but this is a way of debugging your OLED screen by lighting everything up and seeing what retention remained on the screen. So you see here this function clear display, and then fill screen with white turns all pixel on, and that's it. This is all the entire program that is doing. Blink is lighting it up and turning it off, which is basic 05, this one. Not a fantastic program. It's a simple program. It's interesting because practically I'm transforming this entire OLED into a single LED, signal LED, that is signaling something. You see it from afar. Raining pixels exactly like a screensaver from Windows XP, if you remember, or even earlier Windows 3.1. So this is one of my favorite program, because it's lighting up some pixels randomly. You remember the movie Matrix, but there were characters that were turning around. And I thought on making that program here on this OLED display, but it's a complicated program to make. It crossed my mind to make it. But this is a shittier version of that Matrix movie effect, and I quite like it. It's kind of like a space moving like a ship, like in Star Trek, when you are looking on the window and you are seeing all the stars passing when they are in a warp. through space. That's quite pleasant to watch, quite comfortable to see it. This is one of my favorite. And also, after I read about the problem of pixel persistence, if you are keeping the display too much on, this kind of screensaver with multiple pixel moving around, not static, is having a healing effect on the OLED. But don't embrace your feelings yet. This will not repair your OLED. It will only degrade it for the damage not to be very obvious, pretty much. So it will balance the damage with the actual intensity. The entire intensity of the display will get kind of on the middle balance in a way. That's what I've read about it. I'm not completely sure how true or correct it is. I don't have that much time to invest into this little detail. But I'm telling you what I know already. And this is Basic 7. When I put my head and all my concentration into this GIFWix library, and I use all its drawing functions. And there they are. Let me actually zoom in. Are these functions here, core drawing is called, and is this function, I'm making this function here and I'm calling it here in the setup, not in the loop, just in the setup, and that's it. Here I really wanted to test by myself, to wet my feet and my hands with the library to actually learn it a little bit, to actually be a bit more confident. And I'm glad I did it. And I'm also telling you to do the same, to try the same, to play with it, to play with all its shapes. I also have, while I was writing all these functions, I also made, before making this program, I made this file here. This is a file that is having, with a very good explanation, I may add, all the functions inside this library. Here I used ChatGPT to explain to me each function and what it means and how to use it, pretty much. Here it is. I will scroll down to last line here, a complete list of the fonts inside this library. I actually looked inside the library and I find these other 5 font families, and ChatGPT didn't mention them. He mentioned all these ones that you're seeing here, but without these ones. This part is very interesting because this is the default built-in font in Adafruit GIFWix. It's not a file exterior that you load it. It's directly in the same code of the library, pretty much on the same file code. Let me show you how the font family. We are now in the library, and here are all the fonts, and you can see them. And these are the other 4 fonts that I find that ChatGPT didn't mention. And I didn't find this default one. I didn't know how it was called. I didn't find it here in this folder. And then I got the answer that that is called GLKD font, this name here, and what it is actually, that is a part of the core programming. Like I programmed my font, I custom made my characters, this one is the same. Is exactly the same. It's custom made inside the core library. So after I made this file, then I made this program with all these functions, and I was reading each explanation of the functions and what is doing and what is used for and how to use it better. It did really help me a ton. All right, so now to graphics, finally to graphics, and that's it. After this, we are finished. Here I don't have number 14. I also mentioned here that graph 14 is empty. Like I mentioned already, I changed everything a lot. Ray drop, we've seen it already. You've seen the square, you've seen it already. And this one, so graph 04. This is around the edges. This was one of the first animated square, and voila, it's running along the margins of the screen, exactly on the margins. And this is doing all the time. I actually leave it like this in this mode all night long, like the one with the eyes, and I didn't see any screen problems after this one. But I'm happy in a way. I'm happy that I did that test with the eyes, and we will get to it very soon because now I know the limitations, and you as well. This is a very late program that I made, and also this one, but they are here because I had to move everything around to reorder everything, to clean up. Music spectrum indicator, VU meter. So this is only simulating like it's a music somewhere. It's a great idea. It's nicely centered. It's occupying the entire screen. I didn't leave unnecessary empty space anywhere. It's using the entire screen. So rotating fan animation. This is quite cute program. You'll see in a second. It's a cute program. It's a fan that you see it from underneath or from the top. This was supposed to be a test program, but I got nuts with it because it was quite hard to make it. But I made it, and I'm very proud of it. So this is one of the first battery charge discharge animation, when it's filling the screen and then is emptying the screen pretty much, exactly like a capacitor or a battery is charging up and then discharging to 0. That's the idea. And then I said, well, I want it to be on the vertical, as you can see here, horizontally, and now the vertical. So what is now 0.8? Actually, I will skip it because the rest of them are also vertical and vertical. Here I included the text, so I will jump directly to this. This is not having a text on it. This is having a text, so I will jump to 0.9. That's the difference between them. There's nothing special about that one. So this was relatively easy to put the text. As you can see here, simple code in the center and display the percentage where the battery has charged. And as you can see, I'm simulating again a battery that is charging and discharging, and also the the text there, and it was relatively easy because I used the default font from this library, and also that's a square that is also a shape from this library. But then this is a complex fucking code. I didn't realize it at the beginning, but I'm happy I made it because I learned a lot. Holy fucking shit, it was hard, and I also used the ChatGPT to help me, and also the other this Claude, he really helped me with this one because I was lost in the woods here with this code. It was fucking hard. Why it was fucking hard, I will explain it in a second. So as you can see here, all the characters are normally displayed. This is the default way of displaying. But if you want to display the same numbers and the percentage symbol 90 degrees rotated like this, like you're seeing it here, you have to do two things. You have to move the character or the symbol down and up. So the position of it, you have to deal with the position, and then to rotate the actual character, to rotate it 90 degrees. So you have to deal with two functions, and I really wasn't aware of it. I wasn't thinking on the position part of it. I was thinking only on the rotation, and it took me a couple of good hours, like 5 or 7 hours, to figure it out, to realize that I need to actually move the fucking letter, not to only rotate it. And that was a big mistake. An interesting lesson to me. That was a little detail behind the scene I stumbled upon. That's why it was complex, because I had to deal with this shit. And the code is a bit more complicated than that. These are the patterns only for the digit, and here is the percentage, you see, symbol. I'm only using these characters. I don't need to add the alphabet. I'm cutting the memory down a little bit, and yeah, it's a lot of too much shit, too complicated, unexpectedly complicated. But it was a very interesting lesson. An expanding spiral 11. It's okay-ish. It's an interesting idea. It's a test program. To be absolutely sincere, I am not fan of it. I don't see any purpose to use it. Probably maybe as a screensaver. Yeah, I'm more a practical person. It's kind of fun to watch, to hypnotize someone. That's good for, but I never succeeded, especially women's. I didn't manage to hypnotize them at all. Chessboard pattern was a little bit tricky to make. I circled back kind of, and I made some simple programs at the end of this entire graphic testings. I had some errors, very strange errors. The last line was shifted, and I don't remember what was the cause. The last line of the squares, the vertical and horizontal lines. Let's see this one. Yeah, this was actually a very simple program. I didn't have any problems with it. Yeah, now on the eyes program. So 15 here. So these are my first eyes that I made. So I leave this program overnight, and I got that burn-in image retention on the full lit screen. Well, lesson learned. Then after I made my own eyes, so I find this guy, who is an Indian, I believe, by the name, and he is having very nice. I really like these eyes. He inspired me, I may say, and I find his eyes on GitHub, but they are not all of this. It's only one single sample, and I believe it's this one here on the right side. And let's play it. So I searched for this guy eyes, and I found them, and I downloaded them, and I believe he used them. As you can see, it's a different screen size, and I adapted his code to my code, my 128 with 34 pixels, what I'm having. His is 64. Yeah, you see, and this is his code that I got it from GitHub, like I said, and it's working. But the irises, the black circle in the middle of the eye, he didn't have it. He only had the squares, and that's it. So I've added those black irises in the middle. So I took this program with the squares, exactly this one that you are seeing here, and instead of those squares with rounded corners, I converted them into full circle. Right. So as you can see, it's nice-ish. Okay. All right. So this is the program. I wanted to make an hourglass, like waiting hourglass, like in Windows, waiting symbol or icon. Yeah, you see from Windows when this is an old icon of waiting. You know, when the program is loading and is showing you this hourglass that is running, flipping, and it failed because I put ChatGPT to make it. It's kind of working. The shit is all over the place, so that's not good. It's a fail. And another fail, digital fire simulation. Here I had a very interesting problem because I run out of memory, and I didn't know this about Arduino. But Arduino is having apparently 2 kilobytes of memory that you can store your code in it, 2048 bits. And this is kind of a fire, but it's looking like shit, like garbage. And I don't like it. Why I run out of memory? Again, I put the ChatGPT to make the code, and the other one, Claude IE. Originally, he made a high-resolution flame digital fire. everything run out of memory, and I had to lower the resolution down, and I get this shit. So this is not good. I need a way better memory. So this is a very interesting problem. I never had this problem before, to run out of memory. Maybe once or twice in my entire life. Usually I'm not making that big of programs. But with Arduino, and especially with this little OLED display, I'm starting to stretch the limits. And the fucking last program that I wanted to show you is Graph 20. Okay, so let me play it first and show you what I'm having. So I was having this hourglass issue. I didn't know how to draw that hourglass. I made it literally by hand, and it was so painful to do it by hand. And then I remember, yeah, I can use actually an icon. I can take it from internet, and I can convert it with that conversion program, wherever it is. I close it already from internet, like I showed you with the cat, and I still didn't like it. And I said, I want to be able to make my fucking own shapes, my personal customized shapes. And I want to make my shapes pixel by pixel. That's how crazy I am. Why? Because remember when I made the characters and the symbols and the numbers, that was like a training to think in pixels. And that's why this idea came into my head to make a program in C# to create a program to help me draw pixel by pixel much more easier than changing the binary text like I was doing, like I showed you already for the characters. Let's go into my program and show you this marvel of technology that I made. Pixel drawer here. And here it is. So now we are jumping into C# territory a little bit. The program is made. It is working. Partially, all this movie is also because of this program that I finally managed to make it. It took me like 2 days to make it. I kind of moved quite quickly with this program, but I stayed non-stop on it. I was so invested into making it. I put all my effort, all my everything I put into it, all my time, all my concentration, everything. I didn't eat, I didn't sleep. I just stayed and fucking make it. And I did it, and I'm very, very proud of it. And you will like it as well. It's one of a kind, I believe. What I really did here, I made a simulator in a way of this display. I created all these pixels. So what I did, I made a control. It's called pixel grid control. This is the control. It's a blank element, but behind that element is having all this mambo jumbo code. For some of you is mambo jumbo. For me, it's completely normal code, and relatively easy to understand and follow. Here you can see this control. This blank control that is showing here as blank, but here is from this point here until here. Let me actually draw it on screen. So from this corner until this corner here, this is the entire screen. It is comprising of 100, exactly what is written here, 128 pixels by 32 pixels. It's in its entirety. So let's see how many fucking pixels do I have here. So 128 times 32 equal 4096 pixels in the entirety of the grid. Cannot zoom in, unfortunately. You have to kind of see that is the background that is showing under the black squares. I can change it very quickly, the background, to actually see, let's see, like this, you see? Now you can see clearly that the black pixels, you can see between them, background. So this is the grid element. It's having these two lines, one vertical and one horizontal, smack in the middle. And I purposely made these two lines because I'm a genius, and I will explain, I will get to them very quickly in a second. This is the functionality, how it's working. I will not get into the code of this program. I will only present the program, how it's working. I'm very happy of this program that I managed to make it, and it's working absolutely brilliantly. So with left mouse click, you are drawing a shape, and if I'm right-clicking the mouse, I'm deleting the shape, okay? So it's having this two very easy functionality. With left-click, drawing. With right-click, deleting, all right? All right, very easy to do. Well, not easy to do, actually. It was quite complicated to do, but very intuitive how to draw here on the canvas. As you can see, I'm using this quadrant here, or whatever quadrant I want, but to stay in its limits. Before I implemented the mirror, I had it without these middle lines, and I really wanted a way of mirroring, but I didn't know how to mirror it. And this was the genius side of the program, of the design of the program, by adding this very simple and very intuitive middle lines, and they saved my program. They saved my ass. Everything became very easy to make, and very practical and very straightforward how to make it. And now, if I'm mirroring on the vertical line, so from left to the right, well, not that one. Well, I messed up the codes maybe, but doesn't matter. It's doing the thing. Let's see if I'm deleting that and I'm mirroring. No. If I'm deleting that and I'm mirroring, you see, if he is finding more pixels into one quadrant, is adding the pixel to the other quadrant. That's what is the logic of it. That's the algorithm of it. And I already made the hourglass, and I made a function for save and load the drawings that I'm making. So let's see. Let's go into the load and test shape. This is the shape that you are seeing here right now. I'm having it already in this program. I can actually add like a little some other details, like this little leaf. You can mirror it, you cannot mirror it, doesn't matter. I will leave it like this, and here I will make something else. I don't know, a little square probably. Yeah, it's very weird shape, okay? So now I will convert this image, and I will get this element here. And I also have it, if I'm pressing convert again, look here on the top, it says bitmap copied to clipboard. So I'm having it here in this text box, but also on my clipboard. So I don't have to actually select anything here. I have it on clipboard. I only have to press Ctrl V to paste into my code here. So here I'm having this test program, testing. This is the testing with C#. program, and I'm passing this entire block of code. If you are paying attention, I'm getting, including this comment, because it is automatically changing these two variables values, and that's important for the correct execution of the program, because these two variables here and here are actually used in code to center in the middle the image. If you don't want to center, I'm talking here on my actual display, you can use whatever x, y coordinates to move your image around. Doesn't matter. In this case, I'm kind of mimicking what I'm obtaining on my simulator here. Also to check the size, how good the shape is, and everything. So what I'm doing, I will select this code that is already here. I will press Ctrl V, and it will paste this entire code that you are seeing here. And like before, the entire shape that you are seeing it here drawn here in pixels is already here. You can see it here with 111s. Is there with 111. Right now I have to save it and upload it. And it will appear the same image like here, but with those elements in plus that I've just added. Now you see some square and some little triangle there, and some little leaf. Let's zoom in a little bit. Yeah, I cannot zoom in more than this, but you can see it. You can see those two little shapes that I just drawn. What this simulator is good for. So I was confronted with this dilemma, with this problem, how hourglass shape that I wanted to draw. I want my hourglass to be from the top or very close to the top of the screen, of the OLED screen, to the very bottom of the OLED screen, like that. I wanted it this big to fit the entire screen, not to be a little shit here like that and that's it. This is what I was getting when I was making all the tests originally, I was getting this little shit, very, very small, very shitty. I didn't like it. So that's why I made all this program to actually size properly, to make use of the entire fucking screen. And it worked absolutely perfectly. I'm super happy about it. And let me actually load the other test file, my hourglass. This is my hourglass that I drew it before, and let's actually convert it. And I already have it copied in my clipboard, and now I only change this text code here and upload it, and you will see. You can actually see the hourglass here where the ones are. You see here. I can draw it very quickly like this. Yes, here ones, like that. You see, and the rest are zeros, and voila, it appeared there as well. When it's super zoomed in, you can see those little jagged edges, but from afar you don't see shit. You actually see a little curvature on the bottom and on the top there. I also can save whatever I want, whatever I'm drawing here. I can save it on the save file. So let's say I'm adding some pixels here, okay, this thing, and I'm saving it as this hourglass 1 or maybe 2 or B, hourglass B, and save it. And let's see, down at 0. So here, and this is the file that I just saved. And look how, when I'm opening this file, is actually having all this text that I needed here in my Arduino sketch. I'm having it as well in my save file. So it's this entire block. If I'm copying directly from here, I just press Ctrl C from here. I selected it, I press Ctrl C, and now I'm pasting it here, Ctrl V, and now I'm uploading it. Remember, I've added a little shit there. It will appear as well here. So right now it's loaded from my file that I just saved. And voila, the little shit is visible there. That's a very, very nice functionality to have. And also, if you don't need to mirror anything, if you want a simple object just without mirroring of any kind, just draw the fucker. And you don't use these two functions. Also, I have a clear screen. I'm clearing everything. Very easy to, And if you want to make a, I don't know, like this. I don't know what is this. Like a hamburger maybe, and 2 eyes, I suppose, and a little tooth and some strands of hair like that. And you want to animate this guy and move it around. You can do that as well. It's not obligatory to use the mirror buttons, only if you need them. So now if I'm saving this as a test, I don't know, one, save it, and it appeared here. Let's see, its code is there. You can see the little guy, the little face in the ones that are there. And let's see, convert it. Let me save it again because I didn't convert it. I should replace that test one. Go here and paste it, and let's upload it. So right now I'm not using any mirror function, so you will see that this mirror is only to help you make something symmetrical, either left or right or up down. It's absolutely made without any mirroring of any kind. And lastly, what this code is doing is taking all the pixel data that I'm having here and is converting it, as you already observed, into binary 1 and 0s. But the smart thing about it is he is making a virtual square that nobody is seeing, is only in the code. That virtual square is checking where is the first bit that is open. So pretty much like this, is creating this square, is searching for when the first bit is lit up and is starting to calculate from there, and then is searching for the last bit that is lit, and this is the horizontal line, and then the top bit and the bottom bit, which are the extremes. He is searching for these extremes, left, right, and top, bottom, and he is creating this virtual square or rectangle, and this is how is adding these numbers. You see here, this very important numbers is adding them automatically, because this entire bitmap is dependent on these two variables to work properly, to move this bitmap around. That's why these two variables are so important. You need to move them, and you move them, you see from here, you use those variables to actually move around or animate the image. I hope in the future I will not need other more important variables than these two. I believe these are the minimum variables that you need to animate anything. I didn't animate any of my drawings that I'm making here, but I believe it's good enough what I'm having. This is not the last program. Actually, this is the last program that I made. This text 11, this is how I'm ending this movie with, and text 11, and I will upload this. I didn't use my custom text here or my custom font. I just used the GFX library, and voila, I'm having that text 10 volts. So you see how much I'm going into the rabbit hole if I'm putting my mind to it. I am not a programmer, I am not an electronist, I'm just a simple guy, I'm a simple artist, I'm the average Joe that is putting his mind, his effort, and his concentration into one thing to do it right, and that's all that it takes. You need concentration, and you really need something to want it bad enough to make it. That's all I'm transmitting, that's all I'm saying here, that's all I'm presenting to you. My next electronic project will need voltage display, and I was thinking to add 7 segment displays with LEDs on them, which, by the way, I'm making a parenthesis here, they are way more better to use in long-term usage, like leaving them open to run, I don't know, even months, even years, and nothing will happen to the LEDs. They will not burn in or fade out like these pixels on this OLED. And with this, I'm closing the parenthesis. I was thinking on those 7 segments displays to use, but after I find this little LCD, in the back of my mind, I kind of knew I have it, but I wasn't sure if I have it anymore and where I have it. And after I find it, I said, well, this is perfect for my next project that I'm waiting for some components to arrive. I will use a DAC, digital to analog converter, from Arduino, using I2C protocol to communicate with that DAC, like you are seeing here, and also having this display on I2C as well protocol. So I will have 2 modules, this LCD and that DAC, digital to analog converter chip, on the same bus. When I'm sending the bits from my Arduino into that digital to analog converter, on its output it will increase the voltage or decrease the voltage, however the code will dictate. So if it will be binary, it will send a set of bits in a certain order, binarily. And this display here, actually a function in my program, in my future program, it will convert those bits into voltage, and it will show the voltage that is coming out of that digital to analog converter pretty much. It will show me what I'm getting at that output. So this little display here is absolutely perfect and absolutely gorgeous to have as an option to actually see the voltage that I'm working with, that I'm sending from my computer or from my Arduino outside of that DAC component. So this is what this LCD was meant to use. I did learn a lot. I wanted to learn about it, and now it's not that big of a mystery how to use the fonts, how to use the graphic elements, how to convert images. Maybe if I want in the future, maybe I will change this volts letter into a lightning bolt, like a little image. Let's say if I'm crazy like that, if I really want to add a little image made from pixels, I can fucking do it, but nobody else can do it quickly and efficient with my program that I'm having. That's what I'm saying. This is what I'm bragging with, how well and how good I can make things, and how professional I am, and how deep in the rabbit hole I can get into if I put my mind to it. But I did my job. I did put a lot of effort. I did a lot of concentration to actually make something interesting, and to have a lot of spare codes for the future. If I want to make something very quickly and I want a test code that I can change, I can look behind here in these test programs, these test programs that I'm having, and I can just move through them and find something and and use it. Yes, pretty much this is it. Okay, thank you very much for watching. Thank you very much for listening. I hope it helped you in some way. Even if you don't understand everything I said here, but at least you are getting out from this little tutorial that I made here. You are getting out with how to work with binary, how to work with Arduino a little bit, how to work with a certain library, how to think about a library, how to deal with the library, not to be afraid of libraries, to actually download the fucking library, like I did here. You see it here? This 300 kilobytes, to actually download it and enter in it and actually look inside it and find its little details, like how many fonts it's having, how many stuff it's having, the example it's having. Even if you don't understand everything that I'm saying, all the code that I made, even if I didn't present the entirety of the codes that I'm having here, doesn't matter. What it matters is the idea, what I wanted to do, what I wanted to make, what was that thought pattern that I walked with developing all these test codes. So with all this said, I hope you like it. I hope it helped you in some way, in one way or another, to understand one side of things, or the total side of things. If you didn't understand everything, at least one side to understand it, and to see that there are easy ways and there are hard ways to do things. Again, I hope it will help you somehow, and if it's helping you somehow, do leave a thanks somewhere, and leave also a like for Mr. Q12, your favorite artist electronist, and see you later when I will make the next project. With this, I will say goodbye, and sayonara, and guten tag, und auf Wiedersehen, and до свидания. Bye bye. From your favorite artist electronist, Mr. Q12.